Awesome. So I just put together a couple of slides for this webinar. And as Prang mentioned, we wanted to cover primarily the state of image and video generation and what's happening today. Both from a technical perspective, what kind of models do we have? What are the capabilities that they come with? And what kind of hardware and softwares do you need to kind of run these models? And also on the business side, what can these models be used for? Can they be used for, marketing applications or visual effects applications? And what kind of compute do you need to really kind of, make that happen? So before I get started, I thought I'll just take this opportunity to introduce Segmine to all of you. Uh, as Prang mentioned, we are a API platform, and we provide generative model APIs to all the developers who are creating applications using these generative models. Uh, a lot of people would have tried deploying these models by themselves, but what we realized was deploying these models itself is a very intricate and cumbersome task. You have multiple GPUs to handle, sometimes even for a single model. You have the CUDA, QDNN, the stack that kind of usually creates some kind of bugs and issues when you're trying to deploy these models. You also have a lot of tinkering to do with the server APIs, or the, let's say, Flasks, Fast API, Triton, something that you're using to serve these APIs. And these are just the basic applications or apps that you need to deploy, but you also need monitoring. You need to make sure that the APIs are running at their highest efficiency and performance all the time. So that's why we created Segmine APIs, where you can get started with off-the-shelf models. All the APIs are powered by VoltaML, so you are going to get the fastest latencies in the world. And we handle millions of requests for our clients. So, developers who are just getting started, who are just getting like 10 or 20 requests a day also use us. But companies who are getting millions of requests a day also use us to deploy their models at scale. And because of VoltaML, we have decreased the compute requirement drastically. And that translates into a lot of cost savings for the end customers. And that's how you kind of that's how we kind of help our end customers really convert what was not monetizable to a monetizable business model. So
yeah. Sorry, Rohit, one question I think from the audience, just to clarify, right? So when you say companies are requiring millions of API requests, what kind of companies would this be that require millions of API requests in a day for, image generation models, right? So
great question. So although the applications are still starting, we're seeing a lot of marketing companies who already have a interface. For example, although we don't serve, let's say, Canva, but Canva has like a image creator built in. So marketing creative applications who are already at scale are typically users who are doing millions of requests every day. And the biggest could be Adobe, if I'm not wrong. So they are the kind of companies we're seeing millions of requests. Also, there are a lot of enthusiasts. So you should check out this site called cvitai.com, where you have like millions of users coming in to try out new models. So it's a repository for Stable Diffusion models. And that's also another place where we see a lot of use cases being built around Stable Diffusion. So we're still kind of seeing this grow. So there are only a handful of players who probably are doing it at millions of calls a day, but hopefully within 3 or 6 months, we will see a lot of other players also get into this scaled deployment for Stable Diffusion.
Thanks.
Hope that answers the question. I'll continue with our, this deck that it created. To just give everyone a background, maybe someone's not that technical here and hasn't entered into the generative space yet. So what is a generative model? Basically, these are the new kinds of machine learning models that are able to generate stuff. Any algorithm that can be used to generate content, which could include text, images, videos. Sometimes you're seeing simulations, codes, all of them come under generative models. And majorly because of the transformer breakthrough that happened and a couple of other breakthroughs that have happened, we are now able to create content as close as a human could create, or sometimes even better than how a human could create. And So stable diffusion is one of the models. So before I enter into stable diffusion, you can take this as a proxy to just learn about the whole diffusion process or image generation and video generation process, right? So uh, what's happening is in image and video generation process models, you have typically two workflows. One is text to image and image to image. So you can either create something from scratch. So you just write a prompt. A prompt is basically a string of words that is describing what you want. Or you could also give in some image and ask it to edit that image. So you can either create or edit using these models. And what it does is sort of a magic that happens in the middle without getting into too much technicalities. And it creates or edits whatever you have asked it to do. And an exciting part about this is that you have an unlimited space, a latent space, as they call it. So if you really don't like the output that you get, let's say for Santa sitting on, horse or whatever, you can always change something called a seed and get unlimited number of outputs. So that's the capabilities that these models have. Uh, by the end of this webinar, I have a couple of cool demos that will connect all the dots for you. What is a seed, and how can you change all of these parameters to tweak the exact output that you require. But having said that, in a nutshell, these text to image models are capable of generating and editing images and videos. Videos has its own intricacies. We will come to that, but that is the capabilities that these models come with. There are a lot of models. I wouldn't say a lot of, but there are a handful of models out there that are capable of doing this. So stable diffusion is the flag bearer in the open source side of things. We had 1.4 or 1.5 come out, which is the first kind of stable diffusion version that was open sourced around July, August of 2022. And since then, there's been a lot of updates, both architecturally and by the community, where they've taken this model and trained it on different sets of data sets to customize it for different use cases. So as you see, stable diffusion 1.4, 1.5 are the early versions, and then 2.1 seem to be really good. But there is, as we speak, Stability AI is releasing SDXL, which seems to be like much better than 2.1 in terms of the quality of images that it can create. Also, the size of images. All the previous versions by default were creating 5 and 2 by 5 and 2, whereas SDXL is able to create 1024 by 1024 by default. So that's an exciting string of updates from the open source community. There's also another model called Kedinsky. Kedinsky is a model by a bunch of Russian scientists who created a diffusion-like model, but with multilingual capabilities. So you can kind of feed text in Russian language or maybe even Hindi. I'm not very sure about that, but I've seen some examples of Russian languages for sure, and it's able to create images for you. And it's also pretty artistic, and it's sometimes compared to Midjourney. Midjourney is another model that's closed, but is well known for the artistic capabilities that it has. It brings out really realistic and high quality images. So Kedinsky is compared to like open source Midjourney of sorts. We also have DALL-E from OpenAI, which sort of kind of fell off after the GPT hype came up, because I think they started focusing a lot on GPT applications and GPT based use cases. But DALL-E was one of the early models that let you create images out of text. So before I get into the use cases or how to use it, there are a lot of use cases that are coming out, and these are very early days of stable diffusion. So whatever use cases I'm showing you today is basically just getting started. So we are seeing, a lot of tree-based use cases. So e-commerce, there's product image use case, but there are so many use cases being created under, let's say, only for product images. So uh, hopefully within 3 to 6 months, we should see a lot more use cases come in each industry. But to give you some idea, we have seen a lot of use cases crop up in visual effects or VFX side. Animation companies, movie making studios are using diffusion-based processes to create characters, create scenes, create buildings, whatever required a lot of work before in 2D and 3D sense is now being created with diffusion processes. Uh, You have e-commerce use cases, especially in fashion, where you are able to kind of tweak the model, tweak the race of the model, change the clothes by just prompts, change backgrounds depending on what time of the year it is or whom are they marketing to, has been really popular in e-commerce space. Uh, the models are also kind of customizable to edit your images, and hence you will see a lot of new pipelines come up in editing space, and the most famous one being the Adobe Firefly example that you've seen. Like, you can just mark an area and say, make it look like water, reflection, road, and it just does that for you. So those are the applications that you're seeing on creative and image editing side. There are
So,
more.
one question,
Fashion is
one question on this, right? So
yeah.
till now, image generation had been something where for designers would design stuff, right? And agencies would be given to it. So would it be fair to say, given the state of these models today, let's say e-commerce founder, he wants to experiment with his creativity, he could just try out some of those prompts and then create images, and he would not necessarily need to use the agency, at least for the MVP.
Most probably, I think it'll converge. So now companies can do their own prototyping in-house with just prompts. And as well as agencies can now create much richer ideas to kind of, help the client get better at marketing. So both of them are possible as long as you're able to understand the capabilities of these models, have a expert of sorts in-house. So right now, these models are not very straightforward to use, and that's where a lot of tools are being built to simplify this. Uh, a month or two back, Harish, who's my co-founder, and me were discussing, dude, if you're able to do stuff with prompts, I think that's the future. But what we're also seeing is there are a lot of audience out there who don't know prompt engineering or who cannot learn prompt engineering. So there has to be tool sets that will kind of make these things promptless again. So I think it's a cycle. Prompts made it simple, but again, it'll get promptless, where pipelines will come without prompts. You could kind of edit and create stuff. So I mean, everything is possible now. Companies, non-creators have become creators, and creators who are learning these techniques are able to use these techniques to enhance their quality of work.
Thank you.
Awesome. So yeah, there's gaming asset creations that we have seen as well, especially in 3D. So although you can create 2D game assets, we are also seeing 3D game assets being created, and the same applies to visual effects and animations, where we've seen an example where you can say a Coliseum looking like or cladded with marble, and you will get a Coliseum 3D model with marble cladding on it. So a lot of interesting use cases, and the effort that now you require to create these interesting assets are going to be 100th or 1000s, and the number of assets that you will see in the world will increase, digital assets that you're seeing. And I think it's coherent to the whole meta narrative that's coming in. I think this will feed into that narrative as well, because a lot of objects can be created just with prompts right now. We've also seen web development use cases where you can just say, I want a page that is a profile page, looks like Instagram, but has a product shown instead of images, etc. And it's able to throw out like 10, 20 ideas for you. So by no means these are these are the only applications. There are hundreds and maybe thousands of applications that are cropping up. And I mean, as Segmind, we are able to see these applications firsthand. Students and developers are building these out as we speak, and we're seeing lot of new applications being built. And in fact, that was the whole idea about this webinar as well, when Frank and we were talking, that this will help spark a lot of ideas and existing founders, engineers, and help them build their custom workflows for different use cases. So let me just talk about a few important terminologies that you'll come across if you haven't already heard about it. As I told, text to image is basically creation of image using text, using a prompt, and you can create realistic, artistic images based on these prompts. And this is basically the 101 of generative AI in images. The second common narrative that you'll come across is image to image. Image-to-image pipeline is typically a pipeline that takes an image and a prompt and edits the image for you. Sometimes it takes a lot more data than just image and prompt. Sometimes it's a mask. So for example, you can just mark an object and say, change this Bisleri bottle to Kinley bottle. Let's say that's the application. So you can do that with just a prompt, or change it from a water bottle to a wine bottle. It can do that for you, where you also send additional information of where that bottle is. In painting is something that you will come across, or you would have already come across, is basically where you paint a small area in an image, which is coming out of image to image pipeline. And you basically tell a prompt and say, please change this part. So it's basically a offshoot of, image to image pipelines. Outpainting is something is something that you do with an image where you expand the image in a non-technical sense. It's the unlimited zoom that recently Midjourney released, right? So that's outpainting. So you start painting outside the image and you start adding more context. We've seen these use cases in animations, movie making, but also sometimes people are using this in marketing, where different ad sizes are required. Like, for example, you need 300 by 300, but also you need 900 by 300. You also need 700 by 400, and you can use outpainting to fill all of these ads very creatively for you. Deforum is a library project that is taking Stable Diffusion and helping people create videos out of it. They are an offshoot of Stable Diffusion, focused on creating videos out of the diffusion process. And another important terminology that we've come across, or you'll come across, is ControlNet, where it's basically Stable Diffusion plugged in with another algorithm. It could be edge detection, it could be color detection, it could be post detection. So these are usually traditional, old school OpenCV based algorithms that have been there. For example, detecting edges using canny edges was pretty common, but using that over Stable Diffusion is helping you achieve a good amount of control over the images or outputs that you get. I'll show you some examples again, but that's what ControlNet does. And most probably, if you're building an application, you will be using control nets, because it lets you control Stable Diffusion to a great level. So we wanted to kind of talk about fine tuning. That's basically what the whole webinar's agenda was.
Sorry, Rohit, maybe we can pick up some questions from the Q&A. There are a bunch of 4 or 5 questions, I think, which we can answer right now.
Absolutely.
Yeah, so you can also see them on your screen. I think if you see the Q&A panel, I'll speak out some of those. So sure. One of the questions asks is there work being done to generate results from prompts from various other languages? Like, is language translation plus prompting effective? I'm assuming, for example, let's take a Hindi prompt and then convert it and ask Stable Diffusion to create something out of it.
So we've seen, as I told, Kadensky embed this kind of multilingual capability into the model itself, and that has created better outputs. But the better word is very subjective. So, but it does look better than Stable Diffusion. So we do see a lot of new diffusion models being multilingual, but the effect of the quality of images that are going to come out is still unknown. But since we brought out the idea of meddling with the prompt, instead of English, it's Hindi. We've also seen prompt enhancers being kind of an important part sometimes, where you just write a small prompt. You say, a car, green car, but it goes to a LLM that then enhances the prompt and is trained for that particular model. So we could look at something like that for even other languages, where you could embed it in, you could input it in one language, and then an LLM is used to translate it into another language and then send it to diffusion. So all these pipelines are coming. It's just a matter of time before we see these happening.
Great. Next question is, I understand, are there any companies who are using this in production? Any particular examples you would like to highlight, which come to your mind?
So it's been probably 4 or 5 months since all of this kind of hell broke loose and everyone started creating these pipelines. So I'm sure a lot of companies are using this in production. I mean, as at Segment 2, we are working with a lot of clients. Unfortunately, I can't tell the names right now, but there are pretty big clients who either come from studios background, who have created billion-dollar movies, who are leveraging these technologies either to market or to repurpose their existing content. We are seeing a lot of e-commerce sites, Shopify sites also use these plugins to market effectively. So a lot of people are using this in production. Now, uh, I mean, exact use cases depends on which company we're talking about. We have seen use cases even in non-creative sites. So, for example, we have looked at applications where you are able to prompt for a video that an autonomous vehicle can see. So, autonomous technology needs a lot of long tail videos to train their model. So, let's say you have never seen a cow on the road, but you now want to create a video of cow coming onto the road. You can just prompt and that gets created. So I wouldn't say they're being used at production level yet, but I think all the effort is being made to productionize this soon. Over the next few months, we will see them enter into production, use cases.
Yeah, I also just posted the Coke made an ad using generative AI. It's available on YouTube to watch, though they got into some hot controversy with it, but that's an example. Yeah, I think let's probably roll a little bit forward, and then we'll take more questions as we go along.
Sure, Brian. So about fine-tuning Stable Diffusion. So as I told you, Stable Diffusion is the open source version of text-to-image model and image-to-image model. And because of that, since December, January, a lot of work has kind of gone into it. A lot of developers have tweaked it architecturally, or sometimes tweaked it with new data sets and customized it and updated it for different use cases. And that's created a whole set of creators who are fine-tuning Stable Diffusion for their own use cases. So what is fine-tuning, right? So you have the default weights that got open sourced, or you can choose some other weights that that's been over and over kind of retrained. But you start with a weight file, and then you take a set of images and certain prompts, and then you update the model with that data. So what happens with that is the parameters inside the model gets updated, and it acquires task specific knowledge, while it's still retaining the whole general capabilities that diffusion comes with. So for example, I can fine tune diffusion to create fake microscope images or synthetic data for faces, for let's say facial recognition algorithm of sorts. So it lets you update the model for your use case. Sometimes the use cases are very different from where we start. For example, just an image generation, which is like a generic image generation, to like, let's say, a synthetic microscope image. But sometimes they're also being used to transfer styles, where you can fine tune a model to make it look like more realistic models or more landscape images, or let's say you want to fine tune a model to make it look like a Cartoon Network, cartoon. So you can do all sorts of things and update these models for your use case. As you can see on the screen, new styles and images can be included in this new model. You can introduce new concepts. Sometimes you can introduce a new product that you've created, so that next time when you say, XYZ bag, laptop bag on a bike, it knows what that XYZ bag means. You can also introduce characters. So I can introduce, let's say I can take 10 images of Priyank and create a model that understands who Priyank is, and then I can keep prompting saying, Priyank standing next to Eiffel Tower with a wine glass in his hand, and it's basically capable of creating those images as well. And people also fine-tune Stable Diffusion to improve prompt capabilities, so that the prompting is better than the default prompts that 2.1 is capable of. You can introduce new words, you can introduce keywords that specifically are tailored to your use case. So that is why people mostly fine-tune Stable Diffusion. And we've seen two major ways of fine-tuning stable diffusion. There's Dream Booth and there's LoRa, and we will get into both of them and what is the difference between each of them. But both of them are technically ways of updating your weights or stable diffusion weight files, which is basically the fine-tuning process to achieve one of your goals that I've shown here. So the first technique that we can talk about is Dream Booth. Dream Booth is something that Google kind of created on top of diffusion as a process to fine-tune the diffusion model. And they created it primarily with a subject in mind. So when I tell, when I say it's a subject in mind, you can take a dog, your dog, or 5 or 10 photos of your friend or yourself, and then that becomes the subject for you to retrain and update the model. So the whole Dream Boot technique, the technique it uses is called prior preservation. So it preserves a lot of styles that you've already trained it with, and then adds this new concept or the new character onto it. And it's predominantly used to introduce characters more than anything else as of now. So the advantage of this is you probably need only 5 or 10 images to update the model, but it still requires a lot of compute to update this model. Sometimes hours of training is required to get updated model based on even just 5 or 10 images. So this is one way of fine-tuning stable diffusion models. And then the next and the more popular, way, which is getting more popularity as over the last 3-4 months, is LoRa. So LoRa is a much bigger concept. LoRa is a low rank adaptation, if I'm not wrong, and basically it's a technique where you are only training certain parts of the model, not the whole model itself, and that makes it a very easy, lightweight approach to update your model. And you are able to kind of train very quickly for different styles, different sometimes objects, but it's not really working that great with objects and faces. But it's a very low compute or low effort way of updating your stable diffusion model. So LoRa applies both. LoRa as a technique applies both to LLM and diffusion. In LLM as well, you have LoRa-based approaches where you don't need to train the whole LLM. So let's say you have an LLM that has been trained on legal data, and now 5 or 10 more new documents have come. You can train the model with these 5 or 10 new documents using LoRa technique without spending hours on training. It gets trained even on consumer GPUs if the model is not big. And the same thing applies to diffusion as well, right? So you can use consumer GPUs, and that's one of the reasons why LoRa is becoming more popular, because everyone sitting at home having 3080s, 4080s, 4090s by NVIDIA are able to fine tune these models for their own use cases. So as you can see, a lot of advantages of using LoRa. Much faster training speeds. Sometimes we've seen the training complete in 10-15 minutes as well. The outputs, the files or the weight files that come out are much smaller because you don't need to share the whole 5 GB, 3 GB checkpoint file. You only need to share the 50 MB or 100 MB weight file that you changed. And hence it becomes much easier to share it across, with the community. It can also understand multi-concepts. So Dreamboot struggles to understand multiple characters and concepts together, but with LoRa, I can introduce 50 new, terms or prompts that it gets updated with. So that's something that we've seen being one of the strong points of LoRa. Also, since if you already have a diffusion model loaded onto a VRAM, which is on a GPU, to swap out a LoRa bit, which is basically just remove the old LoRa and put a new LoRa, is much, much faster than changing the whole file on the GPU. So the image generation and the process to kind of swap the model out and swap the model in also becomes much faster and easier. And one downside is that, intricacies like faces and intricate objects do not kind of get learnt really well. But as we speak, that is also improving, and we have seen a few LoRa models giving out really accurate faces as well. So I think it's a solvable area of LoRa that's being worked upon right now. So that's about LoRa. And before I kind of close talking about LoRa, LoRa's also have an advantages of merging two styles. So I can take two LoRa models and say, hey, take 50% of the styles from here, 50% of the style from here, or let's say 80% from here, 20% from here, and merge it. So that's a very interesting use case, and you can take two or three models, mix match all of these weights to create your own custom models. So that's another interesting spin-off of LoRa that we're seeing these days. Probably I'll just take a quick pause. Frank, let's take some questions.
Yeah, let's do that. So, question, let's take Joydeep's question, which is, do you know of companies that have used Stable Diffusion to create consistent characters across a series of prompts?
Yes, we have. We work with a few, VFX artists as well, and we have helped them fine-tune models where we have introduced like 5 or 10 characters into their models, and whenever they say, let's say James is holding a arrow and looking at a moon or something like that, it creates James as a character with his face. So yes, it started, and we've seen a lot of interesting comic creation, the tools and platforms come out of that, which eventually I think will spin into movie creation tools as well. So short answer, yes, you can embed characters into the model and then use them every time you want to call upon them.
And then follow-up question for me would be that, is LoRa the right way to do it, or should they train fine-tune Stable Diffusion on certain characters? Like, what is the better way?
So I don't have like an exact answer for this, Frank, because both Dreambooth and LoRa are really kind of working well for a lot of use cases. So LoRa is a more newer technique and it's still being experimented upon. And as I told initially, we saw faces weren't really coming that great, but styles were being kind of updated as we fine-tuned. But recently we are also seeing faces being updated. So if I had to take a bet, I think LoRa's would be the bet, and we've seen better LoRa's also come. A newer technique of LoRa that's using, goes one level beyond the existing LoRa technique. So if I had to take a bet, I think LoRa would be a better way to fine tune and update the model as of today.
Any particular resources you would suggest folks to look at? Like, are there any websites or are there any libraries from LoRa from the way that people can learn how to work on LoRa's?
Absolutely. So I think just to learn about LoRa, theoretically, Hugging Face has pretty good resources. You have Invoke UI as well, which has good amount of resources. So Invoke and Automatic 111 are two tools that are in open source and people are using to fine tune models for their use cases. And as I mentioned, there's a website called CivitAI, CIVITAI.com. Which is basically a Stable Diffusion model repository like Hugging Face, but only for diffusion. So you'll find a lot of LoRa models there. There are a lot of NSFW models also there, but I think that's how the industry also. You'll also find a lot of interesting models also there, both LoRa's and non-LoRa's. And I think it will be exciting to see how the community reacts to this new SDXL come out. Someone will kind of take that, tinker around with that, and create a LoRa version so that people can update it using LoRa techniques as well.
Yeah, I think Remco has talked about a specific question, which is, would QLoRa work for Stable Diffusion models? I actually haven't seen QLoRa's. They're used for LLMs, so quantized LLMs. Rohit, would you know about them? QLoRa for Stable Diffusion? I've just posted the question also.
I'm not very sure about that. So I think we will have to do some more research, but quantization is something that we do in Volta ML anyways. It's one of the lowest hanging fruits for optimizing a model. So if I'm not wrong, maybe QLoRa could be like quantized versions of these LoRa models that are much lighter. But I am not very sure about that.
When K7 has an interesting point. So what if somebody uses, let's say, a Disney character and then let's say does fine tuning use it? Then have you seen copyright issues around or attribution issues around art generated from generative models?
Great question. I think this is something I think you and me also discussed. So copyright is still in the gray area because Different countries have different laws that they're coming out with. For example, in Japan, early law says that as long as you have the data in your on your laptop or with you, you can do whatever with it. Whatever you want to do with it. But at the same time, if you're going to use Disney characters and it's going to look very close to Disney characters, I think Disney will make every effort to not let you use it. So I think it's a gray area as of today. It depends on what are you creating and which geographical location are you in. But yeah, you'll probably you'll have to be careful when you're creating stuff, because these models, especially the older stable diffusion models, were trained on copyrighted stuff as well, where stability.ai got into trouble with a few companies, including Getty. So there's no kind of black and white answer to this. Be careful about what you're generating, right? If it's going to look too similar to something that already exists and that's copyrighted, you better kind of have explicit permission or not use it. And also depends on which geographical region you are in. Japan, as far as we have seen, lets you create anything and that belongs to you. But in Europe and US, it's still stricter. So even the data used to train is something that is restricted.
Right. One more question we'll take, which is Vartika. Actually, maybe these two questions can be answered. One is UX designers, which create entire. Have you seen websites and other prototype creations? Those kind of models, are they very production ready right now? Have you seen very good examples of that? And along similar lines is more on e-commerce. So product explainer videos or product documentation videos. Have you seen people do that also?
So on the user interface side, we surely have seen very promising results, but there are a few kind of hiccups before we kind of productionize it. So the best platforms that can productionize these workflows could be the ones that already have the workflows for creating UI. So let's say UiZard, Figma could be the best platforms to leverage these models. So yes, we have seen a lot of amazing user interfaces being created by these models, but to convert them into code, especially in React or Vue, is still a challenge. And that's where I think there's a small gap between what can be created with diffusion and what can be created and end-to-end with an app or with a working prototype. Also, it's a mix of two models. So for example, the diffusion model creates a lot of samples for you, and then one or two of them goes into an LLM to create codes as well. So I think it's still 3 to 6 months away, but it's going in that direction. And all the companies who already have the interfaces are doing everything to integrate these generative models in some form or the other into their workflows.
Got it. Awesome. I think with that we can move on.
Awesome. So as far as the deck is concerned, this is pretty much done. I have a few demos, so maybe I'll just stop and reshare my screen. These are some interesting demos. Just give me 1 minute and I'll just set things up.
Yeah. Meanwhile, what I could do is I could probably show people Civit and share them how it looks like. So let me do that. So as you can see, this is the Civit website. You can go here and see all the different kind of artwork. All of this artwork is generated using AI, and you will have a variety of techniques being used here, like and you can search for let me see if I can. Maybe I'll show you guys a presentation I had done some time back. So this is like different models. So let me know whenever you're ready. I'm just going to show 1 or 2 slides. So this is like the base, stable diffusion model, which you can use to create, and you can see the prompt here. Then you have fine-tuned models, which, for example, Rohit talked about. So this is a model which is deliberate model, which you can download and run, and or I don't know if Rohit, you Segmine, you can do this in Segmine, but you have different, like this is photorealism model, so you can see the face becomes less cartoony, more realistic, and then dream shaper. So as the people have taken effort to train models over certain images and certain styles, and they look better. This is one of the models I like, Lyrial, it almost comic style, but creates more. So these kind of things. And then I'll just skip to one or two other things. So these are some like pics to pics, which Rohit mentioned. And I think Rohit's going to talk about some of these. So I'll probably stop here. Rohit, are you ready for the?
We're ready. Yeah, Prank.
Okay.
Awesome. The deliberate model and the realistic vision and a few more are going live tomorrow. So we just in the engineering team is just getting things ready. So we have made it really fast. So we are excited about that release tomorrow. These models.
Okay.
Let me just share again. Are you able to see the screen?
Yes.
Awesome. So I'll just kind of show you some examples of text to video by a few startups out there. Videos are still getting matured because to contain the context and spread it over 10 seconds, 20 seconds is where the challenge is. But still, we have really good outputs that we're able to see with text to video kind of pipelines. You're able to see the video, right?
Yes, it's a little frame by frame, but it's fine. I think.
Oh, okay.
Maybe you can post the YouTube video on the link on the chat.
I'll do that as well. Yeah.
And this would require like multiple frames being generated and then stitched together. Somebody had asked this question about how do you control the videos. I think this is a good example that since you have to create an animation, each frame has to be slightly different from previous one, right? So
correct. So like there are approaches where it's creating one image at a time and then merging all of them, like deforum, where temporal context is not there too much for quite long. But there are newer use cases, especially runway ML's models are much more sophisticated in temporal sense. So I'll just share the link soon. But this is the video, which is the Gen 2 model by Runway ML.
And Rohit, we can't hear the sound in some. So by the way, it's stuck at ext dot for us. Maybe it's not played.
I think the video is. Let me just put it here. I think even if you Google Gen 2 Runway ML, I think for all the audience out there, you should be able to get it on YouTube. And very, very realistic. Gen 2 is kind of from Gen 1 in terms of video, and the context sticks around for quite some time. So it's deforum. We've seen like individual frames being created, and then after 10 frames, you just lost the track of where it started from. So let me show some interesting, segment demos that we have. So this is basically, before I start, this is basically an internal interface we created. So as I mentioned, Segmind has accelerated stable diffusion to almost like 5x to 6x compared to PyTorch. And here we're using a 4080, which is a powerful GPU to render these images real time. So if you look at this, I'm just turning on real time, and then we're just writing some prompts to create certain assets. So as you see, kind of this enables a lot of new applications. This also applies to videos because now we're able to generate like 1 or 2 frames every second. So are you able to see the video moving, Frank?
Yeah. It's like as you're typing, the image generation is getting modified and updated. It's like real-time view when you do app development and you keep on typing code and then the app modifies. It's pretty cool, actually. Yeah.
Exactly. So this is something that we were excited early, I think a couple of months back, when we saw real-time generation happen on a consumer card. I'll show you
So
a
this
few
is like
more.
sorry. So this is like your Segmind editor, which people can use today, or you plan to launch it sometime, or how people access this?
So we still have it in house. So we're thinking of open sourcing this as well, just with VoltML. Very soon we will open source this. So we don't have an interface for creators specifically. So we're just going to open source and let the community use and develop upon this.
Got it. Okay.
So now that we're talking about videos, this is Stable Diffusion on a video. So oops. So this is my co-founder Harish, and he basically has a prompt window on the right. It's a little crude version running on Linux. So you'll see a little things. Oops. So the right side is a typical Stable Diffusion user interface. He's connected this whole thing to his webcam. So he's typing photo of Tom Cruise space station background. So his face has now turned into Tom Cruise, and a few more steps and the background starts converting into space station. And we are able to do this on a real feed coming through a webcam. So, you know, a fun application that our engineering team worked on to kind of leverage real-time inferencing. So he just changed Tom to Tom Hanks, and then now the face is now Tom Hanks. As I told, early days of development, so the same image doesn't stay. For every frame, it keeps changing. We can work on kind of locking into a single kind of face. So these are comparable to like your zoom filters and stuff. Very soon you'll see like very realistic morphing happening real time. So that's one interesting, use case. Coming to workflows. So before I probably show this, just background, what we are seeing is the value in a product or an application lies in putting together a set of models or actions happening one after the other. So if you really need to use these generative models, Stable Diffusion or any other generative model in itself cannot give you an end-to-end value. You most commonly we have seen something like this where if you can see the screen, this is a workflow where you are using Stable Diffusion first to create an image, let's say a man looking like a crow, and then using a next model called SRGAN, which is another generative model that upscales an image, and use that to kind of make it 4K in resolution. So workflows probably will be the valuable things in future. So a single model, all of them string together, right? One after the other, and the input of one goes to the the output of one goes to the input of the next model is where the value could lie. So this is one very simple example. And a slightly more complicated example is this, where we were storyboarding for a small documentary. And
Rohit, sorry to interrupt. I think just explaining the steps of a workflow, like the simple one you mentioned, right? So I'm not sure if everybody understands the concept of workflow for image gen. And since we have a lot of founders who might not be aware of this, it's essentially just multiple steps of image generation tied together, right? So output of one step going into the input of another one, and then you getting to some sort of a final outcome which is possible for you, right?
correct, exactly. So I mean, these workflows can be as complicated as even using LLMs in the middle, like first taking in a word, then using LLM to enrich that word, then passing it to create an image, right? So typically, as I told, a lot of these diffusion models don't create face very accurately. So you could use diffusion to first create the face, but create the whole image, but the face won't look that great. And then the second model could be something called code formers, which is another generative model that cleans up the face, makes the eyes look much better, the face look much better. So that is a good combination that we've seen. That is then pushed to SRGAN, which is your upscaling model. So that is what we mean by workflows. And basically each workflow is a startup in itself, right? Like if you're able to kind of put together a string of activities happening A after B after C, I think that's where your value lies as a startup.
Since you touched upon it, I see a lot of these workflows are open, like a lot of the models are open source, a lot of the tools are open source. A bunch of these are becoming. So where does the value really lie? Like you mentioned, again, I mean, this is not really a technical question. In your mind, what is the hardest path, right? So, um,
Uh, I think the hardest part right now is infrastructure, Prank. That's where I think, I mean, we have chosen the hard problem at Segmind because a lot of people, if they need to really start leveraging these models, running these models at scale and really fast is where we feel a big bottleneck is. But at the same time, uh, understanding from the market perspective where this could be used, because I'm not coming in from VFX. Otherwise, I could have started a VFX company based on diffusion. But if you understand visual effects really well, if you know how to create assets and what purposes are they being created for, how are they imported into Unreal Engine, etc. I think that's the area where rubber is hitting the road right now. So from a business end, the use cases are cropping up, and if you understand these use cases well, you're able to leverage these models to bridge the gaps and kind of create those use cases. On the infrastructure side, it's surely hard. It's a mixture of deep learning plus compiler engineers plus hardware plus cloud, which makes it a little challenging for you to kind of scale up when you have these models with you.
okay. We'll also take one or two more questions just on this before you show the full thing. So one is with just the demo you showed about your co-founder space changing. One of the questions is, does it mean we'll move to real-time VR XR rendering engines pretty soon?
Very soon. Very soon. I mean, I think it's already done. We have 4K kind of embedding that's happening right now. So very soon you'll see this happen. I mean, I'm looking at your face right now on Zoom, but very soon you can just write a prompt on Write and say, make me look like Shah Rukh Khan, and I'll be talking to Shah Rukh Khan. So I think the use cases I'm not sure of, but very soon that's possible. Use cases could crop up in education, in a lot of areas where you want a character to be in front of you.
And then that brings to one of the questions that's been asked, which is, are there any fake detectors in place to ensure what is genuine and what isn't? Right? How is fake being captured?
Very interesting. So, I mean, at the end of the day, you can detect technically. Yes, it is possible to detect, but again, it's challenging. There are methods where the creators themselves embed a signature in the image when it's getting created, or the output. And that is basically embedded either in the latent space or somewhere inside the image that a human eye can't see, and that's the easiest way to detect. So like
Stable Diffusion does that, right? Like every signature is cryptographically signed by them
right,
somewhere
right.
inside.
So and then we can also add, like Segmind can also add, or whoever is creating can add, and like the creator himself can add. Like, let's say you saw the realistic vision or deliberate model. If he wants, he can add a signature. So in future, he can just take an image and say, hey, this was created using my model. So that's one way. And then you also have a lot of other techniques where you basically look for certain patterns and say, hey, this was created by a AI model, it's not real. So I mean, it's as models become more sophisticated, you have these techniques become more sophisticated, and I think both of them will keep improving, and there should be like a 95% game where 95% of the times you can detect whether it was created or whether it's natural.
Awesome. One more question, which is there is a mention of a particular paper or library called Phenaki, Phenaki. Anand has mentioned that, and for the rest of the folks, I'll just copy it and post it as well to everyone. He's talked about, have you seen Phenaki, which creates longer videos, or have you used Phenaki? And this is the website as well. So I'll just post it on the chat.
I honestly haven't heard much about Phenaki yet. I think our deep learning team was tinkering around with it, but I'm not very aware of what it does as of today.
Yeah, I mean, the space is moving so fast that I think these are new things which everybody's discovering. So that's awesome, right? So that's good.
Yep. I mean, at the end of the day, every day I wake up, I'm learning something is already obsolete, and like the agility that we need to kind of build company in generative space is really high. So I think I haven't really kind of come across this even internally yet. Mikilosh, who's from our deep learning team, could have come across this.
Awesome. Okay. Thank you.
Awesome. So yeah, I mean, concluding the workflow topic. So these are some complex workflows that I can show you, where we took just a image of cardboard boxes and then created some cities and scenes out of this. So storyboarding, the use case was storyboarding for a animation movie. So you could use this to kind of just get snippets of how exactly you want the scene to look like. So that's an interesting use case. We've also seen fashion use cases where, for example, I've taken one input image, and then I can now change the face of the person, the clothes she's wearing, the background, without going to the studio ever again. So that's another super interesting use case, very practical for e-commerce and fashion sites, as I mentioned. So this is another workflow that involves a little bit of connecting the dots, as you can see. But once you connect the dots, you can kind of use it to update the image, edit certain aspects of the image, and use it multiple times without making it look very similar. So that's one, and maybe I can just get into a little bit of actual demos where I can show you some cool aspects of what you can create. So my favorite stuff is Scribble. In fact,
Sorry, one request. Your browser, I think, is in high resolution, so it zoomed out a little bit. Can you zoom in on the browser, like maybe 20, 30? Yeah, that's great. Yeah, I think that's good. Yeah.
Awesome. Yeah, so this is one of my favorite models. So as I mentioned, SegMind has a bunch of models, and we are adding a lot of new models as we speak. But one of my favorite models has been Scribble. So can I use Axel logo, Frank?
Sure, go ahead.
So let me just, so I'm just
giving unscripted, guys, like you can see this happening in, please go ahead. Yeah.
Awesome. So yeah, I am giving a prompt. Let's say I put an Axel logo as an input, futuristic sci-fi city, and then I say generate. And Scribble basically uses edge detection, canny edge detection. This is a control net model, and creates this out of it. And it is,
All right.
I mean, and you don't like this, you can just change the seed. This is where I was talking about seed. So it can give you unlimited outputs. I don't like that. Change the seed, you get one more output, slightly different, right? So I can keep doing this. I can change the seed again. And as I told, all of this happens within a second. In fact, it takes half a second on our GPU, but since it's over the browser, goes to server, it takes around 1.4, 1.5 seconds. So this one looks just too beautiful. Like, I mean, the kind of stuff that this can do is just brilliant. So this is one of my favorite kind of models out there. Maybe I can try it with SegMind as well. So there's some interesting stuff. You guys can play around with your logos for marketing purposes. For marketing, we're also releasing something called Stable Diffusion QR codes. So it'll look like an image, but there's a QR code embedded. It looks really beautiful. Unfortunately, I don't have a demo today. Our team is just taking it live. So maybe tomorrow, if anyone wants to check it out, they can. It should be live. So I can say top view of a city with trees. So here you go. This is like our logo on the left, and the updated kind of image. So these are some use cases. But as we speak, a lot of use cases are being discovered and created, and that's where SegMind comes into play. Like, you don't really need to build this infrastructure from scratch. You can build these workflows. You can understand different use cases and build it without really having to set up your GPUs, models, etc. If you're at a small scale, you can get started with these off-the-shelf models that you have. But we also work with larger clients who have updated their models with custom weights, sometimes custom models, and then use that in a dedicated capacity. Another interesting is this, which is in painting that I told, right? So to start with, this is, you can just say remove object. So it can be used as an object remover as well. So I just say, just remove this stuff. So this is where I actually need to give an input mask, where you need a small interface to just, draw on top of the image. But I can also say, replace that with a wine bottle or something, and then it should be able to replace that with a wine bottle. Bottle or So as the models evolve, I think you'll need to kind of learn prompts. Each model has its own, prompts are also becoming more natural, but I think since it's early days, prompts or prompt engineering is something that people are learning about and understanding what words trigger what kind of outputs in the model. So these are some outputs that I can show. The SRGAN that I showed you was basically taking a small image and making it much bigger. Typically, diffusion models cannot give you like really high resolution output. So you need to use it in conjunction with something like SRGAN to really use it for printing or even for marketing use cases. We have some interesting outputs here. So you can just take a photo of a face and then put a GIF and then get the output. This went viral inside our Discord where Harish and me were trying to, spam each other's Discord. But interesting use cases that we're seeing. This is Code Formers, a very popular model to restore faces and old photos. Again, this is a very popular model used in conjunction with Stable Diffusion to improve the face quality. So yeah, I mean, things are evolving pretty soon, and these are some of the models that you can use to get started. Videos are also in pipeline, will come in soon.
Yeah, I think given the kind of questions we've been asked, it's a lot of it is around e-commerce catalogs, and then closing the entire, like what all things are possible using Segmind for e-commerce catalogs. Maybe your background removal example and the control net examples might also be pretty good to showcase.
Absolutely. So I think background removal, high resolution for print, especially is again, we've seen depth being used for, let's say, changing the face or genre. Like, I mean, you can, for different campaigns, you can change the face and send it. So that's another interesting use case we've seen. Yeah, I mean, e-commerce is a pretty big segment which is adopting. We've also seen architecture. So this model uses architecture-based applications. So you can just, write a prompt and change this to something else, like a futuristic Jetson like bedroom. Right. So we are seeing other applications also come, but yeah, as you told, e-commerce is kind of able to use this practically in their workflows.
This is great. And Rohit, have you come across using nerfs, the 3D nerfs? Is that something which and people are talking about? Are you working on in generative image models, 3D models?
So not yet. We have been tracking nerfs pretty closely. So nerfs are really great, and creating 3D out of just one or two 2D images. But we were working. I mean, I come from a drone background, so the small issue with nerf is the spatial accuracy is not that great. So we are trying to see if certain techniques can be used to improve spatial accuracy as well. They're really great for just quickly creating a 3D model, but unfortunately they are not very accurate and sometimes create a lot of issues or cleanup required when you import it into other platforms.
Great. And a lot of these things. So two questions. So one is, some of these models are open source and people can just use their laptops to generate these images. So why use, let's say, a API like Segmind? So maybe you can articulate that.
Sure. So one is most of the applications using Segmind are being built online. So, they require it somewhere in their workflow. Also, it's very, very slow on your laptop. So even if you kind of, I mean, of course, a few people who have 4080s and all of that, they can still generate fast outputs, but most of them on their laptops cannot generate an image within like 5 or 6 seconds. Sometimes it even takes 10 seconds, even on a 1080 Ti that I tried it out. So that's one difference. And the second is just the turnkey way, right? Like you can just send in a request and it gives you an image out, and you can try out hundreds of models, versus if you're doing it on your laptop, you'll have to kind of swap it out. A lot of work is involved. If you're a developer, I think it's an exciting thing to do. But if you're building an application on top of these models, you would rather kind of start using these APIs and just build on top. And then you can, of course, relook at this if you're at a very large scale and you're paying Segmind millions of dollars. Then you can have a look at it and say, okay, what do I do with this?
Awesome. Oh, awesome. Folks, feel free to ask any more questions. Otherwise, okay, we have one more question is, what is the FPS you're getting on that webcam demo, which you just showed on GPU, and what is the GPU compute? Any idea of them? Yeah.
Right. We have a 3080 and we're getting 50 iterations per second as we speak. So if you do 20 steps, you're able to get around 2.5 to 3 frames per second as of today.
Okay. Yeah, and then Velanki has asked, with Microsoft and Google are both offering Gen AI services for imagery as well as clouds. So how would you differentiate yourself from that? I mean, well, technically it's not
Look,
this
looks
forum is
like
not for.
a looks like a VC question for me.
Yeah, it looks like a VC question. I think Velanki should probably reach out to Rohit directly and have that chat. Uh,
Absolutely. I mean,
yeah, I
just
think
to
they're not getting into
answer
VC questions. Yeah.
Yeah, just
Yeah.
to answer, the way we are different is the ease of use and the speed. So our VoltML is kind of the fastest. As I showed you, it's 0.5, 0.6 seconds that we take to like process the image. And we are developer friendly. So you don't really need to sign up, wait for credits, etc. You can just come log in via Google and just get started with embedding your API. A couple of differences between them and us.
Yeah, I think given the speed at which innovation is happening, a large company like Google and others, they take time to bring out some of these models to market. They have their own costs to it. There's a lot of tooling required on for customers to start using them. Whereas, let's say a segment like Pear could be very nimble in just moving and providing these services much faster. And then, if as long as the workflows are very good, as long as the speed is very good, price is very good, I don't think why should people shift away from somebody using Segment to somebody else, right? And a lot of
Also,
times people don't want locking into the cloud providers also. Right? So
absolutely. Locking in cloud provider is one big issue. The second is the GPU pricing on these large tier one, providers is very high. So the prices on other cloud providers could be 5 to 10x as compared to Segment. Um, Also, internally, what we've seen is, they can't really take a decision on focusing only on stable diffusion. They are a very large company, but as Segment, we've taken a decision of focusing only on diffusion for the last 6 months and just made sure that we have the best diffusion pipeline available, right? So these are some kind of advantages we have that makes a startup come to us. So if you look at it, a lot of startups who are building really cutting edge solutions using diffusion use Segment because we are cheaper, we are faster, and then at early stage we are able to give you much better customer service than these big cloud providers.
yeah. One, I think this is a question for you as well as for me. I think Anand has asked, given the area is changing very fast, how should people think about structuring their workflows and customer workflows and use cases? Right. So you have a team, you have a plan, and then you make up a workflow, then it changes within a few days, right? So, how do we do that? Um, like how should your Segment customers think about the workflows if it keeps changing very fast?
So, I mean, that's the advantage of using a plug and play API. So, I mean, you are able to break and make and break things really fast, right? Without any cost consequences. So you haven't really paid us like $1,000 upfront or anything of sorts for a certain model. So you are free to make and break things as fast as possible because this space is moving really fast, and we also want to move with that speed. So I think the API based approach itself kind of answers that question, where you are agile, you are completely flexible to use an API for just 3 days and just say, hey, I'm moving to a new workflow. And this has happened to a lot of our startups using Segment. So for example, they started using something called ControlNet Canny, and then they were like, no, let me move to Soft Edge because that gives me better outputs, and that came slightly later. And it took them 10 minutes to update the code because everything remains the same, just the URL changes, right? So it took them like 10 minutes to move to a newer model. So it's an advantage to kind of plug into someone like us because you can keep trying new models and the newer versions that are coming out.
Awesome. This is great. Unless we have, anybody has any other questions, we can answer those. There was one question which was posted in the chat window, which is from Rahul, and this question is, I think you can read it, slightly technical. They are facing some issues in auto scaling some of the generative models on top of SageMaker or ECS, and So what would you recommend as a stack for auto scaling some of these generative models? What have you found better between, let's say, the cloud providers, or any tips you might have for scaling these models?
Uh, I mean, that's pretty much our bread and butter. But what we've done is we've made sure that we are leveraging multiple cloud providers to begin with, to kind of scale up. We don't go to Amazon or Azure yet because their GPU pricing is 5x of tier 2 cloud providers. So we've gone to tier 2 cloud providers and built a robust solution on top of them. So it's a win-win for both. We win the cost and they win a new use case that we can kind of build on top of them. Uh, Auto scaling, I mean, it depends. Like, I mean, auto scaling on smaller clouds is really not an option because they don't really have like such dynamic methods to like take a new machine, etc. So we typically manage a large fleet of machines with a good amount of prediction that says, okay, by this date or by this time we will need these many GPUs to be live. I mean, that's a kind of a problem that we are anyway looking into and solving. So a lot of parts are being built around how do you scale effectively without losing a lot of not using excessive number of GPUs to handle the load. VoltaML has played a quite important role because what could be done in 4 GPUs is now being done in 1 GPU, and that helps us a lot to kind of experiment with infrastructure.
Yeah, let me probably just type out VoltaML for everybody so that they can check it out, actually.
Absolutely. Thank you.
Yeah. So
we have one question from Velanki Sriharsha. Do you offer SDKs as well as to power in-app use cases? So our Python SDK and Node SDK will be out soon. We are working on it. So just to make it easier for developers to embed these APIs. If you're interested, maybe just join our Discord, and there is a beta version ready there.
Yep. Then
browser itself. Yes, Shreyas. Maybe I don't know if Harish will let me talk about that, but yes, I think over the next few weeks you will see a lot of interesting UIs come, where you can drag drop different models and create your own workflows.
Awesome. All right, this is great. Thanks, Rohit. Awesome. Thanks for taking the time. I think it's quite an engaging discussion. And folks, please do take note of all the stuff we have posted on the chat. That will be useful URLs for all of you. Thank you for doing this, and thanks for taking out the time. So thanks, everybody.
Thanks, Frank. It was great. Thank you so much.
Bye.
Bye.